Hello everyone. Welcome to today's class. In precision manufacturing, especially in quality control of injection molded parts, accurately establishing the workpiece coordinate system is a key step to ensuring measurement accuracy and subsequent processing quality. Imagine if we cannot precisely position the workpiece, subsequent processing and testing would be meaningless. Today, we will delve into the method for establishing the injection molding demo part coordinate system, with a focus on the application of the 3-2-1 method. In this lesson, we will cover the following topics. Through this lesson, I hope you will be able to accurately master the basic steps of the 3-2-1 method, including determining the 3 axes and 3 origins, and be able to practically establish the coordinate system for the injection molding demo part. After correctly aligning the workpiece, the coordinate system should be established. In the spatial rectangular coordinate system, any part has 6 degrees of freedom, translational freedoms in x, y, and z directions, and rotational freedoms around the x, y, and z axes. By restricting these 6 degrees of freedom, a fixed coordinate system can be established. Here, the coordinate system is established using the 3-2-1 method. After measuring the first reference plane, use its normal vector as the first axis to lock 3 degrees of freedom, for example, rotation around the x and y directions and translation along the z direction. 2. Rotate around the first axis to determine the second axis, and the third axis direction is also determined simultaneously. After measuring the second reference plane, use its normal vector as the second axis to lock 2 degrees of freedom, for example, rotation around the z direction and translation along the x or y directions. 3. Set the origin using the reference to determine the 3 origin points of the coordinate system. Translate the x, y, and z axes to the 3 reference measurement features, locking the last degree of freedom. The method to establish the coordinate system for the demo part follows the 3-2-1 method and the principle of coincident references. First, on reference plane A, take 3 to 4 points to determine the positive direction of z and the origin of z. Then, on reference plane B, take 2 points to determine the positive direction of x and the origin of y. On reference plane C, take 1 point to determine the origin of x or the origin of y, depending on the specific situation. The final coordinate system origin is the corner points of the 3 mutually perpendicular reference planes, as shown in the image to the right. Next, let's establish the workpiece coordinate system through practical operation. First, switch the probe to A0 B0, and then use the joystick to control the probe. Collect 4 points on reference plane A. Press the Confirm button on the joystick, and in the software, obtain the measurement command for plane 1. Rename it to PLNA. Insert a new coordinate system, AE. Select plane A and align the z-positive direction. Then select the plane again, check the z option, click on the origin, set the z-axis to 0, and click OK. Then, use the probe to collect 2 points on reference plane B. In the software, the line 1 measurement command is obtained and renamed to linb. Insert a new coordinate system, A2. Select linb, and rotate it around the previously aligned z-positive direction to the x-positive direction. Click Rotate, and select the line again. Check the Y option, click on the origin, and set the Y-axis to 0. Then, use the probe to collect one point on reference plane C. In the software, obtain the measurement command for point 1 and rename it to PNTC. Insert a new coordinate system, A3. Select PNTC, check the X option, click on the origin, and set the X-axis to 0. After the coordinate system is established, it needs to be verified for correctness. The correct coordinate system origin and axis directions should be as shown in the diagram. Through today's lesson, we have thoroughly understood the method for establishing the injection molding demo part coordinate system, with particular emphasis on the application of the 3-2-1 method. We have learned how to restrict the workpiece's degrees of freedom, how to determine the axes and origins of the coordinate system, and how to establish the coordinate system through practical operation. I hope you can apply this knowledge to real-world scenarios to improve measurement and processing accuracy and efficiency. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next lesson.